right, here we go. Last section of this chapter. We're going to talk about energy and reactions. This is pretty important when it comes to chemistry. It's the last bit. It just basically tells you why and how reactions happen. So let's talk about energy exchanges. So all chemical reactions either release or absorb energy. This happens when bonds are formed and broken in a chemical reaction. Energy can be released as light, heat, sound, or electricity. So when energy is released, there's four categories. So first, we're going to talk about exergonic. Exergonic are reactions or chemical reactions that release energy, kind of like glow sticks. So when you crack them, that energy is released, and then we have our visual of that energy being released. Then we have exothermic, which is a chemical reaction that releases energy in the form of heat. So good version of this would be like elephant toothpaste that we talked about the other day. As you noticed in the video, heat was released, so that shows that there was a chemical reaction. So that was an exothermic reaction. As far as when energy is absorbed, we call those endergonic reactions. Those are chemical reactions that absorb energy. So ice is a good example. When it's melting, no chemical reaction, nothing changes. It's basically solid water going to liquid water, but that does show that there is an absorption of energy. As far as endothermic reactions, chemical reactions that absorb energy in the form of heat. The easiest endothermic reaction I can think of is your own body. It does this to create body heat. So in the cold, your body does this more often than you know, especially when you're trying to release energy into your body to keep it warm. So let's talk about rate of reactions. So reaction rates is how quickly a reaction will take place. Many factors affect the rate of a chemical reaction. We will look at things like temperature, concentration, surface area, catalyst, and then the pressure. So first things first, let's talk about temperature. So temperature is basically the higher the temperature, the faster the reaction. Kind of makes sense. If you think of boiling water, as soon as you start seeing those bubbles, it starts to get faster and faster to the point of a rolling boil. So the higher temperature means that there's a higher kinetic energy. There's more energy for it to put out at a higher temperature. So why does this happen? The more particles that are moving, the more they collide and thus come in contact with each other to react. That is why temperature, the higher the temperature, the faster the reaction. Those collisions happen more often. All right, then we have concentration. So this means that the higher the concentration of something, the faster the reaction. So that means if you have a higher concentration of salt water, the faster a certain reaction will happen, or anything that has a really high concentration. So why? Basically, the more concentrated the reactants are, the more they will collide and thus come in contact with each other to then react. Third thing is surface area. This is really big, not only in chemistry, but also in biology. So you definitely have to keep this in mind. This is like a #1 topic in biology is surface area when it comes to reaction rate. So the smaller the particle size, the greater the surface area, the faster the reaction. So if you've ever, let's take dogs, for example. If you've ever had a really small dog and a really big dog and listen to, say, for example, their heart rates, a smaller dog will have a faster heart rate than something like a big dog like a Great Dane will have a slower heart rate because the surface area in a smaller dog is greater than that of the bigger dog. I know that's kind of backwards to think of, but that's what I think of. So why does this happen? So again, the more surface area, the more room there is for the particles to collide and to react with one another. This is why things happen faster with, say, for like these sugar cubes in the sugar example. A faster reaction will happen with sugar rather than with a sugar cube. It takes longer to dissolve this anyways. All right, catalysts. Catalysts are substances that speed up reaction rates by lowering the activation energy needed to start the reaction. So it doesn't change the reaction, and it isn't actually considered a reactant or product. It's kind of just there to help lower the energy needed to get that reaction started. So when potassium iodide was added to soap in our elephant toothpaste example, and hydrogen peroxide when we made elephant toothpaste. So that potassium iodide here was our catalyst. And you kind of heard her mention that in the video. Last but not least is pressure. So the higher the pressure for the gases, the faster the reaction rate. It only affects gaseous reactants. This is the only one that has a specific state of matter. It does not affect solids and liquids. So for gases, if you highly pressurize, let's say nitrogen gas, it's more likely to have a faster reaction with something else than it is if it was a solid or a liquid. So why does this happen? The higher the pressure, the smaller the volume, causing more particle collisions. All right, let me know if you guys have any questions or have any concerns. I am here.